The air conditioner stopped working, and I'm in a soup jacket. Welcome back to the Narrow Gap. We're going to talk about mixed numbers and improper fractions today. When dealing with improper fractions or mixed numbers, that is to say, fractions that represent more than one whole of something, the most common question that I find is,
can we work in partners?
Guys, guys, can we work in partners? Can we choose who we work with? Mr. Burke, can we work together?
Partners?
What's going on with that eyebrow?
Don't ask him about that. He's probably just sick or something. Mr. Burke, can we work in partners?
no, you can't. I'm your partner now. Mixed numbers and improper fractions and going back and forth between them can be a little weird, can be a little challenging. So today, for you to maximize your learning, I'm pulling out all the stops. I am pulling out a classic in public education, PowerPoint, circa 2006. I'm going to run through a couple of things on there, and then I'm going to jump straight to my whiteboard and pretty much give you free answers on the worksheet that you can download from the description below. So are you ready? I'm actually asking, I'm your partner now. Don't make me tell teacher on you.
With all the flair of a 2001 PowerPoint presentation, I'm going to walk you through proper mixed and improper fractions. I'm betting that you could probably tell apart just from some obvious clues. Let's play a little game where I show you a bunch of fractions and you tell me whether you think they are proper, mixed, or improper. Yeah, see? Little number on top, right? Doesn't seem too crazy. You're correct. That is proper. A little different. Something going on here. You're right. That is an improper fraction. It's got a big number on top and a small number on the bottom. Great. So it's a mixture of two kinds of looking things. You got a big number here and you got a fraction over there. There you go, mixed number. No worries, you got this. This is easy. Numbers are close, but yep, the top number is bigger, therefore improper. Top number is bigger. This is getting easy. That's correct. That's improper. So that's proper. That's a proper fraction. But this is getting kind of easy. Like this is a proper fraction. Great. Okay, that's good. Oh, and there's a big number again. So then we got a mixture. So that's mixed. That's good to know. That's a I'm guessing proper fraction. Oh, yeah, there we go. Proper fraction. Big number. Yeah, mixed. Feeling good. Feeling good. Okay, so wait a minute. Wait. What is this? This is a mixed looking thing, but there's also a big number on top. Oh, I feel sick. I feel sick. I don't know what that is. That's an abomination. We don't deal with that here. Usually it's either improper or mixed, but this is, I don't even know. You're going to normally see a big whole number or a large numerator, but you don't get both. So you don't have to worry about seeing both. So, okay, what is the benefit of having two kinds of fractions? Well, there's pros and cons to each. On one hand, mixed numbers are much easier to communicate when it comes to their values. So like if you went into a shoe store and asked for size 19/2 shoes, it might be technically accurate, but it would be generally incomprehensible. No one would know what you're talking about. Meanwhile, improper fractions can be easier to use in situations requiring calculation. Without jumping ahead too much, this is a fraction subtraction question, and it might be a good example. Even with these matching nines as denominators, there's going to be some borrowing and some thinking when it comes to subtracting one from the other. It's technically solvable, but if you switch them around to improper fractions, you get 19/9 and 17/9, and 19 of something take away 17 of something makes for a much easier mental math task. Okay, so what have we learned about this so far? One, it's good to understand both types of fractions. That's an easy one. People who defend their actions using the word technically should not be allowed out in public.
Finally, don't judge a fraction by how it looks. You know, I found something recently on social media I'd like to show you.
Oh, can I please use your telephone? No, you can't. We have a sign that clearly states we refuse service to improper fractions. Who are you to come in here and bother the paying customers? Do you not know that my father is the manager? I doubt you could even afford anything here. I drive a $300,000 Bugatti while you ride a $300,000 bus. I bet that you are also trying to steal my phone also. What are you doing? I just wanted to use the phone. Help! Help! Police! I am a real police. What seems to be the problem? This filthy improper fraction broke in here and is trying to break the store valuables. He is also threatening my life. Wait, son, you don't understand. This fraction is actually the owner of the company. I'm so sorry, sir. I will now disown my son. I am a failure as a father because of the way you judge others. You do not deserve fine things. Oh, but father, I had no idea. It's against the law to lie. I sentence you to jail. No, I will never have a chance to do better in life. You will stop discriminating against improper fractions. They are no different than you or me. Yes, boss. Thank you, boss. Wow, we really learned a lot in that video about just how to be a person, you know. But let's learn about how to switch between mixed numbers and improper fractions also, so we can check just a lot of boxes on our journey towards personal growth. So, I mean, at a glance, this fraction is mixed. It's a mixed number. You got a whole 1, and you got 3/7 on the side of it. So to break that down more clearly, you got the 1 whole, like I said. You've got 3 parts out of a group of 7 potential pieces. So just visualizing the most important thing here, this 1 whole, if you were to take this 1 whole and share it up, it would also be broken into one group of 7 pieces. Okay, so right now you got a whole, you got 3 parts, and then everything's out of 7. Now, let's break that down so that we can turn it into an improper fraction. Let's take that 1 whole and share it up in the way that the fraction tells us to, and then combine it with the 3 pieces that are just sitting there floating around on top. So we take this 1 extra group. This should not be a hard question for you. 1 times 7 is 7. I say this because 1 whole broken into 7 pieces shall be 7 pieces, which you then add to the 3 pieces, right? And then you got 10 pieces. 10 over 7. Hopefully the way that we describe that tracks. It's got 10 parts. Formerly 1 whole and some leftovers, but now 10 parts. And 7 would be needed, any 7 would be needed to make 1 whole of something. Okay, let's do the opposite of that, and maybe we'll get a little picture or a little something that we can look at to make sense of this. Okay, this fraction is obviously an improper fraction, right? Big number on top. Things are broken up into groups of 3, but we've got 8 of them. So we could combine at least 1, if not more, of these 8 to make whole groups of 3, and then we just see what we have left over. So to ask that another way, the question is, how many groups of 3 can we make out of 8? Well, what I've got pictured here are 8 thirds. You can see very easily that these thirds would very nicely go together to make a whole circle. And then there's 1, 2, 3, and those 3 would go together to make their circle. And then there's 2 on the bottom here, but I think you could probably tell by the overall shape of all of these little figures that any one of these is a third of a circle. So you got one group, you got the other group. Oh, you put them together, you got 2 wholes. And then you got 1, 2 leftovers. I'm not crazy, right? You see it too. You see it, right? Like it's, oh, by the way, I know that it seems very dangerous for me to put a certain mouse in my videos if I don't want to get sued into oblivion, but hey, guess what the news has been saying lately? Yeah. Fair game, kind of. Anyways, like the picture was saying, you've now got 2 whole circles, and you've got 2/3 of a circle. 2 and 2/3. Hey, look, I know this is a lot to take in, but think about it this way. You can finally find a use for remainders. You remember remainders, right? Like you'd be learning long division. And you'd be sharing or going into the numbers over and over again, and you'd be subtracting over and over again, and your work would just be sliding on down the page like a turd on a hot cookie sheet. And then at the end, there'd be that little bit left over, right over there, just one left. And you'd be like, what's that? And your teacher would say, don't worry about that. That's just the remainder. Just put it up there. And you'd be washed in an unsettling feeling that your answer is somehow pointless and totally unreliable as a result. Like, you really can't do much with that, right? You can't mow lawns all week and then earn 59 remainder $1. That doesn't seem like it makes any sense, right? Well, okay, now you've got a use for remainders. Here is a very hopefully short long division question. How many times does 3 go into 8, to borrow long division language? Well, 8 is bigger than 3. You can therefore make a couple groups of 3 out of 8, right? In this case, you can make 2 whole groups out of 8 by taking out some groups of 8. You make one group and then you got 2 groups, and you've used up 6 of the 8 in making these 2 groups. And then you subtract that 6. You subtract that 6 and you get 2 left over. And your answer is 2 remainder 2. Well, this remainder 2 is going to be the numerator of the fraction in the mixed number. Because with this over 3, it explains what this little remainder 2 is. It's actually 2/3, 2 wholes, and 2 parts out of a group of 3 pieces.
Okay, so I took 4 questions, as you can see, to practice with off of your worksheet. So basically, this is free answer time. If you've watched for this long, you should be rewarded in some way. Because this activity has a lot of airplanes taking off and a lot of airplanes landing, I wanted to break down the type of operation that you're doing, because you're basically doing 2 different things. You're doing something for these questions and something slightly different from these questions, but they're opposite. I'm going to show you what I mean. I took the 2 improper fractions that I selected and put them over here that I have to turn into mixed numbers, and I took the 2 mixed numbers and I put them over here to turn into improper fractions. I'm going to break down what I was doing a minute ago in the other piece of the video, the other chapter, by saying that what I'm doing over here is multiplying and then adding, and, something very specific, not just numbers at random. And on this side, dividing and kind of subtracting over here. And I'll show you what I mean by that. Okay, to start with, I'm going to focus over here. I've got 4 3/7, which means that if you want to imagine this in pizza form, 1, 2, 3, 4 pizzas, and then one that is broken into shards. And we'll assume those are all sevenths. I mean, they could be, right? I don't know. I didn't draw them that carefully. But it means that these 4 whole pizzas need to be speaking the same language as these sevenths so that you can combine them all together. So each one of these pizzas would be cut into 7 slices. Well, this is hopefully a clue. If there's suddenly 7, oh man, 1, 2, 3, 4, 5, 6, 7. Did I actually do that? Oh, I'm amazing. Wait. No, that's good. That's legit. 7. I won't do them over and over. I'll say there's 7 slices here, plus the 7 slices that you'd get doing the same thing over here. Chop, choppity, chop. And the 7. And the 7, you are adding 7 to these leftover 3 pieces 4 times. And at the point where you're literally saying times, it should be a clue what you are doing. It is 4 times 7. So you're multiplying the whole number by the denominator. And then you're adding the pieces that you already knew about, the little itty bitty pieces. So it's 4 times 7, which is 28. And then you're adding 3 more. So this is a number that you get after doing a bunch of stuff. I'm going to just share with you one insight as a teacher. It is not uncommon for students to do the hard math right and then the easy math wrong, or make some kind of silly mistake. They'll say, okay, I got the answer. The answer's 31. I did it. Cool. But then you got the answer wrong because you forgot something. You forgot, oh yeah, this is a situation where it's 31 over 7. I've seen a lot of students skip this last step where they just go, Meh. So in this case, we've got ourselves a numerator and a denominator and no whole numbers over here. Next question over here. I'm not going to draw this one because hopefully you remember what I did last time. You have 6, do you want to say pizzas? Do you want to say just 6 whole circles? Or just 6, the number 6? But next to it is 1/6, which means that we have to break these whole numbers into sixths as well. There are 6 of them. They are being broken into sixths. And 6 times 6, 36. And don't forget, little baby cousin over here gets added on as well. And you get an answer of, so there's 1 free answer, there's 2 free answers. And remember, the steps over here are bottom number times big number added to top number. So these questions require division, and then I'm saying subtraction, but you'll see what I mean in a second. If you like using multiplication on the calculator for these questions, great, you're going to have no problems. But to do these questions with a calculator requires a little bit more thinking than this side of the table. If I was to say, how many groups of 9 can I make out of 41? Well, the easiest way to turn that into a calculator question is go 41 divided by 9. And I get 4.55555 if I'm repeating. Well, that does not really help me. I mean, where do I put that? Well, good news is this 4 part is actually pretty helpful. The decimals are not, but we can kind of ignore them. You see, if I said, how many groups of 9 can I make out of 41? Well, I can make 4, and then there's going to be some leftovers. So this 4 point, no matter what happens here, I know for a fact that I can make 4, and then something over 9. Okay, so how many did I use up? Okay, some more steps are involved here. So I'm going to say, how many did I use up? I have to multiply 4 times 9 and go, hey, I used up 36. This number had better be smaller than this number, because if it is larger than this number, you went and did something foolish. But it should be smaller. So what I'm going to say is 41 minus 36 should give you an answer that is a number, a whole number, and it's got to be smaller than 9. In this case, 5. Another way to demonstrate this in action is to say 9 goes into 41. If you remember how to do long division, not everybody's first choice, but 9 goes into 4, no times. 9 goes into 41, 4 whole times. 4 times 9 is the 36 that you already used up. 41 minus 36 is the 5, which in days past you would call the remainder, but in current time you call the numerator. If division on demand gives you a disgusting, nauseous feeling, there is another way to do this. It takes more steps, but it works. Essentially what happens is you take 59, to use this question, and subtract 8, and I've got 51. One whole group. I've taken one group of 8 out of there. And then I'm going to subtract 8 again. And just subtract 8 over and over and over again. And every time you subtract 8, you know that your whole number is 1 bigger. That's not 11, that's 2, I guess. 3, and so on and so forth. You can subtract over and over again until this number is so small you cannot subtract 8 from it, and that is all the groups that you've got. And the number that you've got left, when it's so small that it's smaller than 8, is your numerator. If that number is a 0, you know what you got? You get yourself a whole number. So if you do this question, if you do any one of these questions, and you get like 2 and 0/10, well, I mean, it seems excessive, right? You could just say it's 2. Well, just keep an eye open for that on this worksheet. Yet another way to do division on a question like this is to just write the 8 times table out. Just on a, side of the page that you're not really going to need later. And all you've got to do is find the closest number on that times table without going over. In this case, it would be 7. 7 times 8 is 56. So if I were to take 56 little bits, 56 eighths, because that's what is being described here, there's 59 eighths. If I was to take 56 of them and put them together in the little pie slices, I could make 7 whole circles, pizzas, whatever. I would be left with a few leftovers that I would have nothing to do with except make a fraction on the side. I'd say, okay, these are eighths. I have 59 eighths. I have used up 56 eighths to make this. How many are left over? 3. I confess that the work on this side, once you get used to the rhythm of what you're doing, is going to snap by a lot faster. This side requires a little bit more brain power, but if you want to use a calculator, just use it wisely. If you want to write out the times table or consult with a times table, you should do it, right? What's important here is that this number is smaller than this number, and this number is smaller than this number. If you did this question wrong and subtracted 8 and subtracted 8 and subtracted 8 out of 59, making group after group after group, and made this fraction 6 and 11 over 8, you've given yourself a mixed improper fraction. I hesitate to say that it's wrong. It's not right. It's kind of clunky and weird. It does describe something of the same value, but it does it in such a bizarre way that no one's really going to take you seriously, unfortunately. Because this number is bigger than this number. This means that out of this 11, you should be able to make at least one more group of 8, which we did, leaving 3, which we had. This happens sometimes, so watch for it. When you're going from improper to mixed, just make sure that your numerator is now smaller than your denominator. I suppose it is obvious at this point, but I'm going to just say it anyways. At no point in any of these questions is the denominator going to change. There's no reason for it to change while going from improper to mixed or back again. The denominator is going to stay the same. If a request is made to you to reduce the fraction, okay, that's a separate discussion. But I am not asking you to do that on this assignment. So the denominator for whatever question you're doing is going to just stay the same. I hope you'll join me for my next video, which is going to be about adding and subtracting fractions. I know you're thrilled. I know you're excited. Please calm down. It'll be out when it's out. Till next time.
Just got lightning crack in the background.